Hello, welcome one and all to the 4th official episode of Dyllon Explains Everything. My name's Dylan, and in case you couldn't tell by the title, I'm the one explaining everything, including today's topic, combinatorics. I'm going to be running through a lot of facts, so if you're curious as to where I get my information, check the description below for a list. So what is combinatorics? Combinatorics is the study of combinations and permutations of objects and groups. I know it sounds thrilling, but it is very useful. Let's say you have a group of 24 shirts, and you have to see how many groups of 3 shirts you can make out of it. This video will help you figure that out. Before I get into any of that stuff though, I need to get into a few basic stuff. For example, a factorial. A factorial is basically, if you have a number factorial, then you're multiplying that number times that number minus 1, times that number minus 2, all the way down to 1. For example, if we have 5 factorial, symbolized by 5 followed by an exclamation point, this is really equal to 5 times 4 times 3 times 2 times 1, which turns out to be 120. Suffice to say, these numbers get really big really fast. Knowing this, let's take 5 things. It can be anything. In this case, it's badly drawn dots. Now, we want to find out how many different ways can we order those 5 things. Well, we know we have 5 objects. So the first object can be any of these 5. So it'll be one of these 5. Then the next object will be one of the other 4. Now we don't know what 4, but it doesn't really matter. Because when we multiply them, that just tells us that for every one of these, we can have 4 other ones. Now, then we have 3 left. So there's another 3. And then we've got 2 and 1. We multiply them together, which is the same as doing a factorial. This is called a permutation, which is basically just the ordering of a set of objects. But there's a bit more than just taking that number factorial. If we have n objects in r slots, which in this case 5 slots, then we represent it like this, for P for permutations. Like I said, there's a bit more to this than just a factorial. What this really is the amount of objects factorial over the amount of objects minus the amount of slots factorial. So what if we had 3 slots instead of 5? Well, supposedly this would be 5 factorial, which is 120, over 5 minus 3 factorial, which is 2 factorial. So let me show that. If we had 3 slots, in the first slot there could be one of any of the 5 objects. Then there could be one of any of the 4 remaining objects. And then one of any of the 3 remaining objects. But then we don't have any more slots, so we don't multiply anymore. This is the same as this, but we're just taking out the 2 times 1. Which is 2 factorial. Now, what if we had a combo lock? Now this lock has 4 slots on it that can have any whole number from 0 to 9. But you remember that your combo did not have any number more than once. How can you figure out how many permutations there are on this lock? Well, you can work this out if you don't know the equation. You know that in the first slot, there can be any of 10 numbers. Then in the second slot, there can be any of 9 numbers. Then in the third slot, there can be any of 8 numbers, and then 7 numbers. You know this because each time you go through, you use a previous number, so it gets smaller by 1 every time. You then multiply these together, and you get your answer. We could also work this out with the equation. In this case, we have 10 items going into 4 slots. So that's what we're trying to work out. So what this becomes is 10 factorial over 10 minus 4 factorial. Now, this can also just be simplified down to 10 over 6 factorial, which is really 10 times 9 times 8 times 7 all the way down to 1. Over 6 times 5 times 4 all the way down to 1. Since what happens back here is just this, and we're dividing it out and it's all being multiplied, we can just cancel this out. So this goes away and everything past here goes away, leaving us with 10 times 9 times 8 times 7, which is what we got here. Now, what if you didn't know that you didn't repeat any numbers? Well, it'd be kind of similar to this. It would start out with 10, because there's still 10 numbers that you can choose from. But then for the second slot, there's still 10 numbers you can choose from. And in the third slot, there's still 10 numbers you can choose from. And same in the fourth. All this is 10 to the fourth power. Now, what if you wanted to find out how many permutations there are for the letters in the word read? Well, at first you might be thinking this is kind of easy. There's 4 slots and 4 objects, so we really only need to worry about the number of objects because this cancels out. So we know there's 4 objects, so just be 4 factorial, which is equal to 48. But the letter E is used twice, meaning there's some variations, like this one, where if you swapped the 2 E's, it wouldn't make a difference. Now, in order to account for repeats like the letter E in read, we need to amend our original equation. In the denominator, we also have to multiply by how many times each letter is used factorial. For example, R is used once, so we multiply this by 1 factorial. D is used once, so we multiply this by 1 factorial, but those cancel out because we're just dividing by 1. The key is E, which is used twice, so we do dividing by 2 factorial. The way mathematicians show this is by multiplying the denominator by x subscript 1 factorial, which is the amount of times that the first object is used. In this case, for R, it'd be 1. Then x subscript 2 factorial, which is the amount of times that the second object is used, in this case, twice for E, factorial. Then it goes on for x subscript 3, and 4, and 5, but in this case, we'd only have 3 because there's only 3 objects. In other words, because this is just 1 factorial and it cancels out, this is just 1 factorial, so it cancels out, and the one for D is also 1 factorial, so that cancels out. It would just be the amount of objects, factorial, over the amount of times this is repeating, which is 2, factorial. Which, since we calculated this is 48, and this is just 2, 48 divided by 2 is 24. Now, you may have also heard of combinations. Now, combinations are like permutations, but the ordering of the objects isn't what you're looking at. For example, if you had 2 objects that were completely different, with permutations, if you're putting them in groups of 2, there'd be 2 permutations. Because this would cancel out, there'd be none of this because there's no repeats, so it'd just be 2 factorial, which is 2. Now, with combinations, which we show by the amount of objects, C, the amount of slots, we're just taking the amount of permutations we'd have and dividing it by how many slots there are factorial, because the slots don't actually matter anymore. So let's go back to the problem at the beginning, where we had 24 shirts and 3 groups to put them in. If we're not counting the order as part of the equation, what would we get? Well, we can calculate it, the permutations for it, if the order really did matter, and then we can find out the combination. So in this case, it'd be 24 factorial, and assuming there's no repeats, this would be over 24 minus 3 factorial. Now, this calculates to 21 factorial, and as we established before, if we've got 24 times 23 times 22 times 21 all the way down to 1, we can cancel out anything past including 21 because we're dividing it by that. So what we get is 24 times 23 times 22. This calculates out to be 12,144. Now that's without the combination part. With the combination part, we then have to divide this by 3 factorial, which is just 6. This calculates to be 2,024. There's another way you can do this though. This is what mathematicians call a binomial coefficient, which is really just the combinations that n objects can go into r slots, which if you worked this all out would really just be this. Now, whether you think these are useless, fun to learn, or you skipped to the end because you were tired of me talking, you are all almost correct. With that being said, if you enjoyed the video you saw today, why not click subscribe to see more and click the like button to let me know you did like it. And if you have a suggestion for a Dylan Explains Everything, leave it in the comments below. And until we meet again, my name's Dylan and I explain everything.